how can you build the architecture that guarantees the performance, that guarantees the resiliency like cloud? With that, I'm going to invite my colleague, Pramod, to talk, co-present with me. Before starting this company, I spent a lot of time with cloud companies like AWS and Facebooks of the world, Googles of the world. How can such companies build large-scale data centers, global networks, and manage with fewer people? There's a lot to learn from them. We learned a lot from watching these guys, how they monitor and manage the networks. We went one step further. Even today, the cloud companies, they try to build a lot of technology on their own, but they still depend on third party for the hardware and the software. They don't have the control on the hardware and the software. And you probably heard many times clouds went down, Facebook went down. The reason was human configuration error. We eliminated human configuration error. Learning from what cloud guys have done and taking it further with our own hardware and software so that we can control end-to-end and eliminating the human configuration, we're able to deliver cloud-like resiliency and guarantee the performance. This is a high-level architecture, very simple. As you can imagine, we have the equipment that we deploy at the customer sites, and we have the sensors. The data is coming in real time to the cloud, and we build this Nile cloud platform. I'll give you a little bit insights into that. But this is the cloud platform where the data is coming in, our AI, ML, automation, everything is kicking in, the softbots, and ensuring the networks are always running smoothly. On top of that, our cloud DHCP service is hosted in the cloud. And customers, when they come in and log in, that's the Nile portal that Austin just showed, is it served from the cloud as well. So we have many applications that are running the cloud, and you'll see as we go through it. We're in year 2023. For whatever reason, networking industry thinks that we need to talk about microservices and cloud native. We don't need to. Frankly, you have Uber and you have DoorDash. Everyone who builds the technology today, it's native. It's microservices. That's not the technology. What service am I providing to the customers? That's more important. I was at AWS prior to starting this. We had something called AWS Well-Architected Review. We know exactly what needs to be done. We also had people from the cloud. So scaling and operations, not just locally, but globally. And as you have more and more customers, more and more users and devices coming onto the network, how do you scale automatically? Not just the compute, but from the operations perspective. Security. We have built in from the cloud perspective, not just from the networking, which will go into more details. Cloud security is built in. There are well-architected principles. There are third party that monitors and audits our security posture. On top of that, we have what we call Security Operations Center that constantly monitors our cloud as well. And performance-wise, especially when you have authentication, DHCP, many other services that are coming in the way of user getting onto the network, they need to perform very well. They need to act, they need to respond very quickly. So how do you ensure that you can get that highest performance to end users? That's all built into our architecture. With that, Pramod, let's go into the architecture details.
Thank you, Suresh. Good afternoon, everyone. It is indeed a privilege to stand in front of you and talk about what we at Nile believe is the future of enterprise networking. So before I get into some of the details, and I'd like to talk a little bit about what I call as the foundational first principles and core tenets that we had when we set out on building this architecture. I like to do that always as in my career as an engineer, because that helps as a fundamental sounding board for any architectural direction, decisions that we need to make as we go on this journey. So what are they in this case, right? Wireless everywhere. Users and devices are becoming wireless. Predominance of wireless is unchallenged. It's wireless devices proliferating everywhere. Number one. Number two, if you look at the traffic flow patterns, what we are finding is that it's predominantly north-south because of the move towards cloud and kind of consuming everything as a service model. Right? So that's driving the traffic pattern to be predominantly north-south. And that then brings in the couple other aspects, which is you really need an always-on, highly reliable, and secure connectivity. But primarily, and what is most important here, is to deliver this, you have to drive towards simplification, network simplification. Now, this is something which was a little bit of an anathema from my past days as a high-end router builder. how do I really remove protocols out of the network? How do I drive configurations out of the network? Suresh talked about human errors tend to be the 18% of the problem, or rather the 80% of the problem. Where how do we remove that? The no-ops part of it, right? So that's what is important. How do we make sure that we preemptively detect network problems and kind of have soft bots that will go off and figure out the solutions to that. So this was were the founding principles that we had. It's now based on that, what we did was we devised what can be considered as a building block for our architectural basis. And that consists of the wireless access points, the access switches, the distribution switches. In some cases, the core switches also is part of the entire of this block. In addition to physical wireless sensors that I think we briefly talked about and tried to show you, but now it's out there on the table finally. As well as virtual sensors that are embedded into the access points and other network devices. So this comprises what we tend to call as the Nile service block, or NSP, and that's a terminology that you'll probably see as we go through the multiple presentations. So this comprises the Nile services block, right? And what I really want to emphasize here are a couple of things. This block is designed to be scalable upfront, and it can go down to tens of users per site to thousands of users per site. The block can be repeated and kind of tiled down together, if you will. And more importantly, the second aspect is, I think we mentioned this also earlier, the construction of this block from a architecture perspective, or on a customer basis, is fully automated. So once we have the customer data, gather business data, and Austin just talked about, hey, you just click and enter the information where you want the service, what are the aspects of the service, how large the office space is, and things like that. Then with the site survey data, that all goes into a software service that will automatically build the network architecture, the topology, the connectivity, as well as the BOM, including not just the switches and elements, but also the accessories like, do you need a mounting bracket? Do you need, what kind of SFPs and transceivers do you need in this site? What is the fiber layout looking like? Patch panel, patch cards. All that is fully automated, and that's a critical part of how we can deliver this as a service, like what we were talking about in the cloud model, scalable model. So the other aspect is everywhere this service is deployed, we focus on making sure there is high definition, minus 67 dBm audio video coverage, as well as capacity. And we not only make sure of this just by site survey and placement of APs, but also back it up with what Suresh referred to as continuous site survey. And we will go into more details about that in terms of the RF monitoring and corrective actions that we do. The other aspect is redundancy is right into the architecture as well as in the BOM build out. And that's very critical to how we deliver and always on services, and that redundancy is throughout all the layers, at the access to the distribution to how we connect to the routing layer on top. The other aspect, which we'll talk a little bit more about, is we have done what we call as a single SKU approach, right? So we have a single SKU of APs or switches, access points and switches, and that helps build resiliency into the whole system. And on top of that, to be very clear, while we talked a lot about cloud and cloud management, the NSP, or the Nile service block, operates in the absence of any cloud connectivity because the control and data plane is local. If there are faults, routing works around it. That is fully local and continues to operate without any cloud intervention from that aspect. So that's again primarily important as how we deliver this as an always-on service. Getting a little bit deeper into the software architecture, right? What we've seen, if we may step back into history a little bit, is that the last 10, 15 years, wireless tend to be kind of developed in a silo, if you will. And then when it gets folded into a bigger company, it's just effectively what I call as bolted on to the existing switching technology. And so it unified wired and wireless has been chimerical. It's a promise never delivered. So what we did differently this time was we started with the approach of, hey, let's look at an integrated wired and wireless approach. And we can do that. I think we are uniquely positioned and probably the only one in the industry to do that, because we start from a clean slate and pick the architectural elements to help support that. So right from day one, in terms of whether a user is wired or wireless, whether in terms of policy management, whether in terms of authentication, whether in terms of advanced data plane features or even visibility, it's fully unified. And how we achieve that is through what we call as our intelligent head end, which is integrated into the Nile service block. That does the policy enforcement, authentication, as well as visibility metrics for the users. Now, the other factor that we kind of reflected upon from a history perspective, and I'm as much a culprit as anybody else in this, is layer 2, while seemingly simple to initially deploy, tends to be a little bit of a minefield from an operations perspective. Suresh just talked about 20 variants of STP, MSTP, RSTP, all those kinds of stuff. So what we did is, hey, again, because we had a clean slate, we said, how do we go about this from making sure that it's layer 3 all the way to the access layer, right? And that was another fundamental aspect of how we delivered this. So it's layer 3 all the way to the access layer. We have eliminated STP, LACP, MLAG, HSRP, VRRP, all those, that's gone. It's a simple layer 3 architecture all the way to the access layer. And what comes out of that is that it becomes much easier to now add functions like advanced DPI, advanced QoS that comes out of it, device fingerprinting. All this becomes much more easier to integrate into the whole solution, since now it's fully layer 3 based. So while we talk about this, the other aspect I want to emphasize is that, hey, this may look like it works for greenfield. Actually, no. Almost pretty much, I would say 90% of our existing customers today are brownfield customers. So all kinds of users that you can think of, whether it's employees, whether it is your guests, partners, contractors, you can all bring them on. All types of devices, PoE, non-PoE, wired, wireless, OT devices, IT devices, user-based devices, non-user-based devices. We support all of them. There is no problem with all that. We have the right network capabilities and mechanisms to support all that, while at the same time making sure that it's securely coming onto the network. Like each device is authenticated as well while it's being brought onto the network. So this is capable of going into any brownfield solutions. And in fact, we even operate with your Active Directory system through SCIM identity management protocols, or your DSCP service, or your Radius and your WAN router services as well. Or you could leverage our cloud DSCP service, or guest services, which would simplify things further from that aspect. So again, the two aspects to emphasize here is the simplification of the network, and the fact that this is clearly can address scale end-to-end, as well as there is no problem going into a brownfield. It might sound, because of some of the changes that we have done, or the approach we have taken, I would say, that, hey, this is just greenfield. No, it's clearly meant for brownfield as well.
I have a question.
Sure.
So you're really saying about building a specific Nile service block. The service is net new, so it looks greenfield to them, and you're just doing route integration for the rest of the network? Is that the clear handoff? Are you going into a firewall, or what's?
No. So right now, as Suresh was explaining, what we are talking about is clearly the wired and wireless LAN, and we integrate with the brownfield, whether it's your user side as well as your node side on our other infrastructure like Radius, DSCP, as well as routing.
Right, but my confusion is, you doing layer 2, layer 3 integration?
So if you
layer 3,
top of the Nile service block, you have the SD-WAN or the WAN routers. That's a layer 3 OSPF,
right,
or the static routing, or any of those layer 3. That's what we do.
So in the era of hybrid work from home style environments for a lot of offices, in my backyard, New York City, how does your per user pricing reflect that sort of dynamic environment? Because it sounds like it'll be able to grow, but can it grow on sort of an intra-month level where people have folks coming into work only a couple of days a week, or how is that handled in pricing?
Suresh?
Sure, Jay. There are multiple answers to it, but one is typically, let's say if I have 50 people showing up this month, we charge for 50 people. Next month, 30 people, you charge for 30 people. But Jay, what we heard from many customers, they're not ready for the variable billing. They want more a flat model. So we look at, let's say you have a building that is for 100 people, right? A floor that's 100 people. And we give you a flat billing saying that typically, probably 50% of the people show up. Based off of that, we give you the price per month. Or in other cases, you can also have a lower bar. And as the more and more users come in, then if you commit to only 30 people out of 100, let's say, there's a price for that. And anyone who shows up above that, they'll be charged per user per month model. So flexible model.
Basically taking the total number of users and you're just working out like with the customer hey, we're going to target 80% out of 100.
Yeah, working with you and trying to figure out exactly.
Basing capacity on that. Okay.
That's right.
And that's what, wired and wireless, or is it just?
Yeah, wired and wireless. Okay. Correct.
So now getting a little bit deeper into the elements of, that goes into the Nile service block, right? What is important is that we have designed and custom built our hardware and software as well with enterprise class design in mind. So if you look at our access points, they're high-end Wi-Fi 6E, 4 radios, all of them 4x4 and 4 spatial streams. The fourth radio or third radio in some cases, depending on which model that you looked at, that we referred earlier, is dedicated for RF monitoring, WIPS bids, as well as the sensor services that we need out of that. And why we do that, we believe inherently that using what we call as a service carrying radios for that would lead to inaccuracies as well as inefficiencies in how we monitor. We want kind of always on continuous monitoring, and why we need that will come to later in terms of how we translate this into a business instrument for the customer. The access switches are, again, high-end, single SKU model, so we've built it that way. All ports are PoE capable. But again, there was a question earlier about the port connectivity. So that's why we made it this way, is that you can have that flexibility. And at the end of the day, once you finish the job, it goes back to the cloud and say, hey, is this acceptable or not? And then we say, yes, the job is completed as per our requirements. We have the sensors. We talked about it. 5 gigahertz sensor that works just like a client device in station mode. That's constantly monitoring the access points, the intelligent head end that we talked about, and the infrastructure of the network. And then we have the rest of the network, whether it's applications, the radio servers, the DSCP servers, also being monitored to give a complete end-to-end view. So what's important here, and a couple of things. Again, it is purpose-built hardware with deep instrumentation that helps us deliver this as a service in a fully automated way, right? That level of deep instrumentation you get only when you do your custom-built hardware and software. That's one important aspect. We wanted end-to-end security. There was a question about MACsec. Yes, we do have MACsec all the way to the access point as well as all the way to the end of the distribution layer. So it's end-to-end security. We wanted that. In addition to that, what I tend to call as a secure supply chain, right? So we have at the manufacturing floor where this equipments are being built, we have our cloud provisioning software install Nile-specific security certificates as well as authenticated Nile-signed images, and that helps us to make sure that when this gets installed at a customer site, it is still an authentic Nile device, and if it gets tampered on the way, we are able to detect it and kind of quarantine it out of the network, right? So that secure supply chain is also important to how we deliver a secure service. Okay, I think there were a few questions about the bring up, and let's see if we can address that and take some questions here. So I think Suresh has mentioned that we have a simple mobile app. Effectively, that shows you the installation plan. And again, we have simplified even the physical installation aspect of it. I don't know if we have time towards the end, we can show, I think the access points, Rishit would be able to show you how it's a toolless installation. We don't need even a knife to cut the tile. So we have some patented technologies in how it is a fully toolless installation, even for the access points. Then with the mobile app, we give you a plan of how this should be installed, connected, and all you do is kind of pretty much click a button which says configure. To the extent that none of our systems in production that goes to a customer site does not even have a console port or a management port outside. No humans are needed to configure the system. Once you do that, the system automatically comes up, boots up, gets the IP addresses, connects with our cloud, downloads the appropriate images as required if there is an upgrade, and any customer-specific settings. Like we said, the SSIDs customers can manage. All those settings are downloaded automatically, and the entire service comes up just with that action. So we call this even beyond ZTP. It is really zero provisioning per se.
So I got a question there. So yeah, just with a bunch of deployments and experience with ZTP and all that, it works great until it doesn't work. And since there's no console access, and let's say I'm not managing the DHCP server, I have no access to it, customers managing it, and they're pointing a finger at, hey, my DHCP is fine, I'm fine, it's your device.
So, it's a good question. And in our case, for the Nile network elements to come up, we do not depend on the customer DHCP server.
Okay.
Those IP addresses are assigned automatically by Nile with our within our domain and our capability.
Okay.
So that part is so if there's a problem, it's our problem. We have to address that, and there is no finger pointing or cross domain issues there. So hopefully that clarifies one.
So the main layer 3 Nile service block device will be issuing DHCP handling on the DHCP then?
For the loopback IPs and the device IPs. I'm not talking about client devices.
Okay.
Right?
I have a question here. I was wondering if now maybe it's a good time to get a few more details about how this works and comes up, and what the actual dependencies are to be able to reach, the Nile cloud services and everything. So it seems like it was mentioned earlier that you're depending upon the customer firewall for internet access. Is that an accurate statement?
Yes, I would right now. Yes, Suresh, if you want to add to that.
So, Chris, to answer your question, it doesn't have to be a firewall. It can be a router. It can be SD-WAN. It can be anything that gives us the connectivity to the internet. And going back to your earlier question, right? Yes, we need to be able to reach our cloud. So you need to punch holes, right, in order to reach the cloud. In case if you blocked it, typically, since it's initiated from the network, you don't have to punch it. But if you blocked everything, then you have to punch the holes. That's the only thing. And then, of course, we need NTP, as you can imagine, right? We need some access to NTP so that we know exactly what's the time. So those are the 2-3 things that you have to do in the firewall so that, we can access those services.
Okay, so the general flow is that, I'm provided as a customer with a list of some things that I need to allow outbound through my edge, not firewall necessarily.
Yes.
And that edge device, has to provide some sort of connectivity to you via not DHCP, it sounds like, and something else. And then you can get out to the internet from there, and then everything just comes up, or what?
Yeah, so if you look at, what's in this orange block is what is really the NSP or the Nile services block, right? So if you can think of this as the Nile service gateway or distribution switches, whichever terminology you prefer, this would be connected to the customer router, firewall, edge device, as you call it, Chris, via straight port connectivity. And then the firewall and the routing policies have to be set up to enable Nile devices to communicate outside to internet. That's about it. You don't need DHCP to allow IP addresses for the Nile devices. Not again talking about client devices, but Nile devices. So effectively, you have to set up this connectivity, punch holes in any firewall rules that you have, set up the routing for the Nile devices to reach outside.
Thank you.
Thank you. So moving on, so quickly about the cloud DHCP service, most of this was touched upon earlier. We believe we are probably the only in the industry to offer fully cloud-native DHCP service. So, which means that you don't have to worry about rogue DHCP service in a large broadcast domain, no configuring relay agents at multiple points throughout the network. Nothing of that is needed. Or you just click saying, I want to subscribe to Nile DHCP service. Yes.
You're saying nothing of that is needed. Does that mean that you're putting it together, or that it's not needed at all?
It's not needed at all in our case because.
So you're not even doing your own relays or anything.
No, we are. So let me.
Yeah. So there is a difference. So we are doing the relays, but it is automatically configured. Is the point here?
Okay,
You don't
so
need
it is
to
being done. It's just you're doing it for the customer.
But the difference is also we do not need to do the way that we have unified wired and wireless. We don't need to do it at multiple places in the network. It's predominantly from the intelligent headend that we talk about that we appropriately relate to the cloud in a secure way, again.
I presume you have to do it at least at one place on each network.
Yeah,
Okay,
one
thank
place,
you.
yes.
We're going to show you.
Yeah.
Skip.
Yeah, so I think, again, in the interest of time, we're going to skip through this. Yeah, Suresh. Yeah.
Thank you, Pramod. So guest, all of you know it, how difficult it is. Like if you have one site, let's talk about single site. When you need to set a guest SSID, guest VLAN, or guest VRF, and you have to make sure the entire traffic gets routed to the SD-WAN, the router, and goes to the internet only. If you have multiple sites, it's even nightmare, right? You probably have heard of anchor controllers, where you take all the traffic coming from the controllers, put it in the data center, and put it on the internet. It's prone to a lot of errors. Recently, one of our customers tried to do guest on their own, and they upgraded the firewalls, and they lost rules, and guests were able to access the corporate resources. There are lots of problems. That's one. Second is, one of the healthcare company in Bay Area, they allow, when you go and visit the hospital, right, we get onto the internet, and you download the copyrighted information, and the hospital is responsible for all the digital copyright notifications, what we call DMCA. And for that, what they're doing is they're taking all the guest traffic, pushing through Zscalers of the world, incurring $150,000 a month. So you have security problems, you have DMCA issues, and the complexity not to deploy and manage and monitor this. What do? Extremely simple. You click and saying that you want a guest service, we take the guest traffic from the Nile service block, take it all the way to the POP, and put it out there. You don't need to manage the guest SSID. You don't need to manage the IP addresses. You do not know how many employees show up. So we manage the entire IP addresses for them. Our own DHCP service, our own IP addresses. You don't have to deal with any of that. There's no guest VLAN, there's no guest VRF, there's no routing, there's no anchor controller. All of that is eliminated. And on top of that, the end users are going out to the internet using our IP addresses, not our customers' IP addresses. So the DMCA responsibility lies on us. We reduce or eliminate the DMCA responsibility for the customer. It's really that simple. As we talk to customers, they love it. Because in fact, many a time, they want us to use the same model for their employees as well. Because today in a hybrid workforce, they're able to, they believe employees are much more secured at home than when they come to office, which we'll go into more details why they think so. But here is one example where guest is completely isolated and just go to the internet. Because of all the things that Pramod talked about, all right, the sensors, the hardware, the software, the architecture, the topology that we built, we're able to guarantee the performance to the customers. On a monthly basis, we show you the network is up and running. We have high definition voice and video coverage throughout your building, and you have the capacity for all users and devices and applications. That day we believe we can predict your capacity needs, and we continue to add capacity without incurring any additional cost for that operations. With that, let me also clarify, it almost comes like, hey, everything is taken care by Nile. No, there is a shared responsibility. The network layer side of it, the hardware, the software, the design, the day 0, day 1, day 2, and including site survey, cabling, there's a little bit, cabling plan, installation, activation, all that is done by Nile. And we continue to monitor and make sure the Nile network itself is up and running. But you as a customer have complete access on what kind of SSIDs. We've been talking about intent-based networking for more than 10 years. It was a great marketing story, but never realized. Why? Go ahead.
I had a question. So, I know you're talking about guest wireless and monitoring, for example, but how would that work? So I'm in the legal space now, but I previously worked 7 years in healthcare. How would an instance like that work, especially from HIPAA compliance? And just because I know everything, you need to have the I's dotted, T's crossed, and everything from traffic to the people coming in, patients, the files that are everything. It's just very, in one box. So how would that work in this instance, especially if, we're not monitoring, has the engineer or has the admin or whatever the case may be?
So there are two aspects. There is the employee, and we're talking about only the guest part of it. All right. When the guests go to the internet today, they get on the guest Wi-Fi and go to the internet. All right. So that part, we can give you complete audit of who is accessing the network, what are they accessing, where are they accessing, when, and where are they going. We can give you the complete log so that in case if you need legal reason. But if you want to have the terms and conditions, you can have the terms and conditions before they can get on the network. We also have other capabilities where you can have sponsored guests. I come to visit you and I enter your email address and you can approve it. Or we also have, for BYOD devices, we have single sign-on capabilities. Yeah. So coming back to this, you have intent-based networking, as we talked about. We've been talking for 10 years. Great marketing story. Never realized. The reason is we had all these disparate technologies, and we're trying to do intent-based networking on top of it. Here, you just say, I want employee access everywhere and guest access on my first floor, and we'll take care of the rest. You still have control on the DHCP IP address management if you do want to, and radios, SSO. I'll not go into a lot of details, but everything that you see in the top, to control users, devices, and applications, you have full control on that and their policies as well.